Now I want to look at this problem again, this finding the first and last position of element in a sorted array. So we use the binary search to solve it, but the most languages have a binary search function that we can use. So let's look at how to use the library functions to solve this problem. So it's fairly straightforward to use C++. C++ have these two functions called lower bound and upper bound, which are essentially binary search. So lower bound returns a iterator pointing to the first element that does not compare less than target. So the first element that is greater than or equal to target. And iterator it has a lot of similarity with the pointers. And when you call lower bound, you first pass in two iterator, begin and start point and end point, and then your target value. So these begin and end functions give the starting point and end point of a vector, and the endpoint generally is pointing to after the last element. So yeah, I guess if you are familiar with zero terminated string in C, then this is pointing at the position of the zero if you operate this on string. So here on a vector, so if a vector have n element, then begin point to index 0 and end will point to index n, which actually doesn't contain an element. So lower bound use binary search to find that. So for this problem, after we find the lower bound, we need to check first whether if the lower bound is at the end, so that means all the element in the vector is less than target. So the first one that doesn't compare less than the target is actually the end. So in that case, the element does not occur. We need to return this -1, -1. Also, if we find this iterator, but the value it refers to, we dereference the iterator using this star to apply star to the iterator. So again, this is similar to pointer syntax. If it does not equal target, then that also means that the target does not exist. So at this point, if the code reaches this point, then that means the element exists and the low point to the first place where it occurs. And we can use upper bound to find the last place it occurs. And the upper bound will return an iterator pointing to the first element that is greater than value. So it's point to if there is a consecutive segment where target occurs, this will point to after that segment. So once we call upper bound, then the first element, the first value we return should be low minus num.begin. So this gives the index. So this subtraction on iterator gives the number of element in between +1. So you can think of this as the index arithmetic. So begin point to 0, if low point to 5, then this will give us 5, and that also means the index 5 of the element is pointed by this low iterator. And answer 1 should be up minus this -1, because up point to the thing after the last occurrence of target. So we need a -1 here. So this is how to solve this using C++. Can we solve this in Java using binary search? Because Java actually has a function called binary search. And yeah, I want you to think about that. So Java has the arrays.binary search. So you provide an array, you provide the element, it will return a number. And the semantics is first, the array should be sorted. If it's not sorted, then what's returned is undefined. So it will return some number, but there's no guarantee what it is. Otherwise, if the element is included in the array, it will return, it's called the index of the search key. So essentially, it will contain a index that the array of that index is that element. If the element does not exist, it will return this negative insertion point -1. So essentially, they want to use one integer value to cover all cases. So therefore, if the element does not exist, they return information that you can compute this insertion point, which is defined as the point at which the key would have been inserted. So if we have, say, 1, 5, 6 in the array, and we are searching for 7. Let's say we have 1, 5, 10 in the array. We are searching for 7. Then the insertion point will be where the 10 is. So after the 5, because it's between 5 and 10. So they want to provide the insertion point, but to distinguish from the situation where the element exists, so it's a negative insertion point. But the insertion point could be 0, and the index where the element occurs could also be 0. To avoid ambiguity, they use this negative insertion point subtract 1. So the problem is actually if the element does not exist in the array, then actually this gives you then you get the insertion point, then you can actually solve this problem by just returning -1, -1. But if the element exists and multiple value the element may occur multiple times, then there's no guarantee what this Java binary search will return. So actually you cannot solve this find the first and last just by calling this array.binary search. You have to do something else. So it's actually not obvious what you do other than doing additional binary search, whether you use this arrays.binary search or not. Okay.